is the LOSSAN Rail Corridor. The LOSSAN Rail Corridor is a 351-mile coastal rail corridor that begins in San Luis Obispo and ends right here in San Diego. This corridor is the second busiest U.S. passenger corridor. The Sorrento to Miramar Phase 2 project proposes to straighten out the worst curves in the LOSSAN Rail Corridor on the steepest grades in Soledad Canyon right here in San Diego County. The alternatives analysis has recommended that 2 alignments be carried forward to the environment document, Alternative 1C and Alternative 6. We have to decide which is the least environmentally damaging practicable alternative, or LEDPA.
Alternative 1C, mostly within the existing railroad right-of-way along the south side of Soledad Canyon. Alternative 6, traverses of a new right-of-way corridor along the north side of Soledad Canyon and includes 2 new railroad bridges.
According to the existing alignment chart provided by SANDAG, the existing speed is 25 miles per hour along the existing track, while the freight makes the speed to 20 miles per hour. Here, as you see, is the projected track alignments for both alternatives 1C and 6, including the location of the bridges. The phrase right-of-way refers to describing the ownership of such property. For both alignment 1C and alignment 6, the parking lot of FedEx needs to be acquired for the construction of either track alignments. So using ArcGIS, the projected right-of-way of FedEx is 7 acres of land, while the construction of Alternative 6 will be 15.4 acres of land. All calculations for the horizontal and vertical curves is designed by the recommended practices in the ARIMA Manual for Railway Engineering. Here is a summary table of the amount of excavation and land filling for both alternatives using the maximum and minimum radiuses.
Bridges. 2 bridges are necessary in order to complete the design for Alternative 6C. Although Aeonix Engineering determined that Alternative 6C is not the LEDPA, a bridge design was still required in order to estimate costs for the total project. Bridge 1 will have a total span of 600 feet and Bridge 2 will have a total span of 900 feet. Here are the bridge locations. This bridge design followed an example seen in the Caltrans Bridge Design Practice document that is available online. Due to the location of the bridges, we have decided to use precast pre-stressed concrete girders. Due to the length and width requirements, we have selected the California Standard Bulb T girder CA-BT67. The cross sections include 4 girders spaced at 900 feet every 150 feet. Loading of the bridge will follow ARIMA standards as well as SANDAG standards. Although extremely important in real-life design, seismic effects were not considered in this design due to extreme time constraints and the complexity of seismic analysis. Since it was determined that Alternative 6C was not the least environmentally damaging and was the most expensive, the bridges were not presented in the selected design.
The hydrology study calculates how much water lands in a given area. To find the flow rate of the water, rational method is used. Q equals CIA. Q is the flow rate, C is the runoff coefficient, I is the rainfall intensity, and A is the catchment area. The value of the runoff coefficient will depend on the description and grade of the area. Then match it with the given table to find a value. In order to find intensity, you will need to solve for time of concentration. The Overton-Meadow method is used to find the time of concentration. After finding time of concentration, you can find the intensity value through the IDF curve. To find the catchment area, two calculations were made, one for alternative 1C and another for alternative 6. These are the rational method results that will determine the size of the culverts. The drainage design will safely move rainwater away from the tracks. The ditches will be parallel to the tracks and are 15 feet away from it. The diameter of the culverts will vary depending on the calculated flow rate. The culverts will move rainwater from under the tracks to prevent erosion.
The purpose of this study was to evaluate the existing conditions and develop recommendations for site preparation and appropriate foundation systems for the planned alignments and structures. When researching the regional geologic and tectonic setting, it was discovered that California is divided into 13 geomorphic provinces, in which the Serrano to Miramar project is located on the western side of the peninsular ranges. These ranges are also known as the Lower California Province. They span from Los Angeles Basin to the southern tip of Mexico's Baja California Peninsula. The formations that were encountered at the site include artificial fill, colluvium and alluvium, Linda Vista Formation, Stadium Conglomerate, Scripps Formation, and Ardith Shale. Groundwater. The groundwater appears to be contained or perched within the alluvium. Groundwater is expected to be influenced by rainfall and other sources of local runoff. It may also be present within fill soils, particularly within the limits of former side canyons and tributary drainages to Soledad Canyon. Groundwater is not anticipated for the deep cuts planned for both alternatives 1C and 6. There were several potential geologic hazards that were considered in this project, including faulting and seismicity, surface rupture, soil liquefaction, landslide and lateral spreads, tsunamis, seiches, and flooding, and subsidence. Out of all of these, the only one that was a factor was the soil liquefaction in alternative 6. Earthwork at the site will generally consist of embankment fill, placement, backfill of retaining structures, cuts to expand or create the rail bed, and preparation of the rail subgrade. Excavation characteristics. The soil's alluvium and liquefaction material should be readily rippled with heavy-duty excavation equipment. However, difficult excavation conditions could be encountered during the excavation into the existing slopes. Retaining walls may be required at some locations along the alignment to retain embankment fills. These retaining walls will be cast-in-place retaining walls. The locations of the retaining walls are shown in the next slides. The cost estimate for Alternative 1C included 3 sections: railway items, structural items, and right-of-way costs. Railway items included earthwork, drainage, environmental, railway items, and contingency. Structural items included 4 retaining walls. The total cost of the retaining walls was around $658,000. The total right-of-way cost was nearly $15 million, making the total of Alternative 1C $36,772,165. The cost estimate for Alternative 6 also included railway items, structural items, and right-of-way costs. Railway items included earthwork, drainage, environmental, track, and contingency. The structural items included 5 retaining walls along the alignment and 2 bridges. The total cost of Alternative 6 came out to be nearly $56 million.
What is LEDPA and why consider it? LEDPA is an acronym that stands for Least Environmentally Damaging Practical Alternative. When considering a project's alternatives, it is important to weigh environmental impacts in addition to the cost. The U.S. Army Corps of Engineers requires that when impacting wetlands, the least damaging alternative is preferred. The alternative deemed LEDPA must meet the project's objective. A practicable alternative is one that is capable of being executed after considering environmental impact, cost, and existing utilities. Additional considerations include Section 4F of the Department of Transportation Act of 1966, CEQA, the California Environmental Quality Act, and NEPA, the National Environmental Policy Act. Threatened species that are existing in Soledad Canyon include the California coastal gnatcatcher and the San Diego fairy shrimp. When considering design alternatives in the canyon, it was vital to ensure that these species were not harmed. Our final decision was to deem alternative 1C the LEDPA. We chose 1C as the LEDPA because it impacts approximately half an acre of the Section 4F wetlands, whilst alternative 6 impacts over 55 acres of the Section 4 wetlands